Find the orthogonal trajectory of x square by a square plus y square by b square plus lambda which is equal to 1, where lambda is a parameter. Here we have to find the orthogonal trajectory of this equation. Here this is an equation of an ellipse. Here we have to observe that here the lambda is a parameter. Here AB is not a parameter. Here lambda is a parameter. That means we have to eliminate this lambda value, not A and B value. We have to eliminate lambda value over here. First consider the given family of curve x square by a square plus y square by b square plus lambda which is equal to 1. Here call this as equation number 1. Here first step we have to differentiate this equation with respect to x. We get here 1 by a square is constant, take as it is, into differentiation of x square is 2x, plus here 1 by b square plus lambda is constant, take as it is, into differentiation of y square is 2y, into again we have to differentiate this y with respect to x, that is dy by dx. Simply we can take it as y1 which is equal to, here differentiation of constant is 0. Here we have to eliminate this parameter lambda. For that, take this value to the right hand side. We get as 2y into y1 divided by b square plus lambda which is equal to minus 2x by a square. Here 2 gets cancelled. Here we have to eliminate this lambda value. For that, we have to obtain 1 by b square plus lambda value. So, taking 1 by b square plus lambda means we have to take this value to the right hand side. We get as 1 by b square plus lambda which is equal to minus x divided by a square into y1. So, we get a value of 1 by b square plus lambda value as this. Now, we can substitute this value in equation number 1. We get as x square by a square plus y square is as it is into here 1 by b square plus lambda is minus x by a square into y1 which is equal to 1. Here y gets cancelled. Here also a square value we have. Here also we have a square value. So to remove this a square value, multiplying throughout the equation by a square, we get as x square, here plus into minus, minus x into y divided by y1 which is equal to here 1. Here cross multiply this value, we get as a square. Hence, we get value as x square minus xy by y1 which is equal to a square. So, we can conclude that this is a differential equation of a given family of curve. Because here this is an equation which does not contain a parameter. So, we can conclude that this is a differential equation for a given family of curve. Now, we can replace this value, that is dy by dx by minus dx by dy. Simply we can take it as y1. We have to replace y1 by minus 1 by y1. So we get a value as x square minus xy by y1 which is equal to a square. Here we have y1. So replace y1 by minus 1 by y1 means minus 1 by y1. Thus my y1 goes to the numerator, hence minus into minus becomes plus. Hence we get x square plus xy y1 which is equal to a square. This is because in the place of y1 we have to substitute it as minus 1 by y1. That means here in the place of y1 is minus 1 by y1. Hence y1 goes to the numerator and minus to minus that becomes positive sign. Hence we get x square plus x into y1 which is equal to a square. Take this x square to the right hand side, we get as x into y1 which is equal to a square minus x square. Here take this x to the right hand side, that becomes y into y1 which is equal to a square minus x square by x. This is because we have to separate x term and y term. For that we are doing this procedure. So in the place of y1, that is y into y1 is something by dy by dx which is equal to a square by x minus, we can split this value as a square by x minus x square by x is x. Take dx to the right hand side and by integrating the whole equation we get as integral of y dy which is equal to integral of a square by x minus x into dx. Here we have splitted y term and x term separately and we have to integrate both the equation. We get as here integration of y dy is y square by 2 which is equal to, here a square is constant, take as it is, into integration of 1 by x is log x minus integration of x is x square by 2 plus some integration constant c, or if we taking LCM as 2 and take this x square to the left hand side, we get as x square plus y square which is equal to 2a square log x plus 2c. So this is an orthogonal trajectory for the given family of curve. This completes the problem.